Yo, what up, what up, what up? Y'all know the deal, man. Like and share, like and share, like and share. So get this thing out everywhere. There's anywhere in the world you could be. But sorry, right here with me, the BABGOG, on a Tinfoil Tuesday. And with my man, Big Aaron, bro, in the building. Our resident
Well,
astronomy expert. What's going on with you, bro?
nothing to it but to do it. Usual, same old. Looking forward to yet another scientific conversation. Science and physics and math. Yeah, man. Anything engineering, mathematical. Right?
Indeed, bro. So last week, you know what I'm saying, they had the orbit for the space station, right? I guess to prepare for the moon landing that they're saying I guess we're gonna actually do this time. I'm trying to find the thing. Let's see, was it Buzz Aldrin? Buzz Aldrin.
Yeah. While you look for that, I'll offer a little bit of background. So, if anybody remembers, the first moon missions back in the '60s were called the Apollo missions. Now, the current moon missions are called the Artemis missions. And if anybody's into Greek mythology, Apollo and Artemis are twins, twin sisters, I believe. And the mission plans are kind of sort of following the same trajectory or pattern. First it was just send unmanned vehicle around, then send a manned vehicle around, and then land. So they had slated the next Artemis mission to be an unmanned landing. Or no. They were going to build a lunar orbit space station, right?
Space station, yeah. That's what it's supposed to be. Yeah.
Yeah, the Gateway International Space Station that was supposed to be in lunar orbit. They scrapped that as of March and have decided to create a base on the lunar surface. So there's going to be a series of missions in preparation for that. We shall see.
For sure. Hey, and I think you might have your computer mic selected versus your. Make sure you got your mic selected because it sounds like it's not the computer mic. I mean, it's not your main mic. It's like it's your computer mic. But so the whole moon landing thing within itself, like you said, we talked about this briefly last time. Well, actually, no, we talked about this on Hamp Show, right? Because we were talking about the space races and things like this. So we never even got to this because we didn't get to the space aspect of it, right? So just a little history lesson for the people that may not know. So, way back when, after, the quote unquote Nazis were supposed to be persecuted and locked away forever or executed for their war crimes, America and Russia said, well, hey, there's no need to waste these wonderful minds that were the fucking leaders and progenitors of fucking propulsion systems, aka rockets, right? Now, of course, weaponry was the first way into order to use those things and so on and so forth. But once we start getting into the whole space races, hey, the same thing that's used to propel you a rocket towards your enemy and blow them up can be the same thing used to propel you through the fucking Earth's atmosphere into outer space, right? If I remember right, I think the first successful Russian thing was Sputnik. That was like one of the main near things. And I think they sent a damn. Did they send a dog or a monkey into space first? Oh, we got feedback. Hold on, let me meet you up.
Yeah.
You had an echo. Hold up. Go ahead. Say something now. Say something now.
Check.
Check. All right, we good. Yeah.
Okay. Yeah. I think it was a dog.
I think it was a dog.
I'm pretty sure it was a dog. But yeah. 100%. Sputnik 1 and 2 were the Russian satellites first to leave, Earth's gravity, essentially.
Yeah.
Or go to low Earth orbit. Yep.
And then, like you said, we get into NASA, which from a tinfoil aspect, NASA, the funding for NASA is really, really interesting, intriguing, and partially dark because that's also linked to the let's say the spoils of when Germany was defeated or whatnot, what have you. I don't think people understand how much money Germany had. Germany had pretty much taken over all of Europe, bro. Germany was so rich from a production aspect, and then taking over other nations and shit. I don't know how much gold and shit they had at the time, but I think when they did finally take that stuff over, they had, of course, gold. They had works of art and things that was like, ancient shit that's priceless. It was just crazy, man. So when they finally, had taken Germany back over and started divvying all those things up to all of the different countries that were involved, yeah, bro, that money helped with a whole bunch of different things.
Yeah. Side note, I'm not going to get into this history lesson and how it's connected, but Chase Manhattan Bank has its roots going back to exactly what you're talking about. If you think about the Chase symbol, what's it look like? A swastika that's had the corner paired off.
Yep. Even that, like I said, the swastika symbol, we won't get too far into that, but yeah, even that from a esoteric and Knights Templar fucking Freemasonry thing gets quite deep too. But but let's listen to our man Buzz, man. Let's see what Buzz got to say about us going to the moon.
Why has nobody been to the moon in such a long time?
That's not an 8-year-old's question. That's my question. I want to know, but I think I know. Because we didn't go there, and that's the way it happened. And if it didn't happen, it's nice to know why it didn't happen. So in the future, if we want to keep doing something, we need to know why something stopped in the past that we wanted to keep it going. But I think I know. Because we didn't.
Now, one of the biggest controversies ever was the whole, did we go to the moon? Did we not go to the moon? And now this is where your expertise comes into. You're gonna drive the ship, as we say, right? Explain to people how and why it would be extremely, extremely difficult, especially back in those times. And I don't know if you saw the thumbnail, but we go into Marvel Comics and you look into it, even though they said it was a radioactive like sun thing or whatever that did it, the radiation that will be in the Van Allen belt will be very, very similar to the impact of what they're claiming it to be. But it's your show, sir. Go ahead and educate the people.
So I guess we'll start there with the radiation. As soon as you leave low Earth orbit, or as soon as you leave Earth's atmosphere, you're going to be significantly exposed to gamma radiation, all kinds of high energy particles that are being emitted from the sun. And when you leave not just the atmosphere, but low Earth orbit, you start to move away from the Earth's magnetosphere, right? And I've talked about that before. The Earth is pretty much a magnet, right? The center is iron, and it's spinning in one direction, which creates, a magnetic field. That's why we have a North and South Pole. That's why you have Aurora Borealis. What that is a dispersion of high energy particles in the atmosphere due to the magnetic field protecting the planet. Once you leave that, okay, you become extremely exposed to some extraordinary levels of high energy particles and radiation. You just said it. I can't speak.
Van Allen belt.
Thank you. I'm thinking Van Halen, the band. No, the Van Allen belt. Exactly. So essentially, if you can get through that, that's pretty much like the point of no return. You are really seriously out at sea. Now, to send machines up there is one thing. You can communicate with machines, but there's still going to be a lot of background noise with a lot of radio communication. But to send humans up there, even if you were to lead line the ship that you're flying, right? You're not going to be able to create a barrier thick enough that can be deployed given the chemical rocket technology that they had at the time, right? The chemical rockets, the Saturn V specifically, was a very powerful rocket, but to be able to deploy that kind of a payload across a distance of about 238,000 miles is highly unlikely. It's highly expensive as far as fuel and energy consumption. furthermore, the moon, like I said, it's 238,000 miles away. It's difficult to land on and then take off from. If it's going to require, right, a launch pad and a Saturn V rocket and breakaway fuel tanks and boosters to get there, then how can you get back? Now, granted, the moon is 1/4 the size of the Earth as far as volume, and 1% to 2% of its mass. So you're gonna see a significantly less gravitational impedance in your ability to take off. However, it's still there, right? You still have to be able to launch and develop enough speed. Furthermore, when you launch toward the moon, you got to slow down. And it's not like a car. You don't hit the brakes. You know how to slow down? You got to burn fuel.
Exactly.
You got to reverse thrusters.
You have to create a reverse thrust to stop down. And like you said, you're literally maximum fucking force to punch through the Earth's atmosphere and then get through the Van Allen belt. Right. And then, like you said, be able to have enough fuel reserves to slow down just enough to land. Because even though, like you said, the mass and stuff may be lower, it's still fucking a solid object. So if you go into the fucking moon, it's one or two things going to happen. Either the vessel is going to crush and fucking crumble upon impact. You know what I'm saying? Or like you said, it's just going to be this thing as to where how I gotta say this, a skipping stone. That's what I say. It'd be like a skipping stone.
Right.
Especially, like I said, understanding the technology that we had at that time.
Right.
And then we get into go ahead.
No, speaking of skipping stones, so one thing that we do when we approach the Earth is we use the atmosphere to slow us down.
Yep.
In order to traverse between the Earth and the moon in efficient amount of time, you got to accelerate up to speeds of tens of thousands of miles an hour, right? When you're coming toward the planet Earth at 17,000 miles an hour, you got to scrub speed off. When you land, you got to be ready to be doing 0. So what you do is you come in at an angle, right, in relationship to the Earth, and you skipping stone essentially through the atmosphere and allow the resistance of the atmosphere, the mass of the atmosphere, to slow you down. The moon has no atmosphere.
Exactly.
So you really have to apply reverse thrusters.
Nothing but thruster. Exactly. It'll be nothing but thrust too. And then too, Aaron, this is a first shot success. I don't think so. That's another thing. This has never been done before. All of this calculations and mathematics that we have theoretically, right?
Right.
For you to get that right the fucking first time and the only time,
right?
You got a better chance of hitting the lottery twice.
Exactly. So there are also some other details about the moon that are a little more esoteric, but I think they're worth mentioning. Number one, like I said, the moon, as far as volume, is 1/4 the size of the planet. But its mass is only 1 to 2% of the planet. How is that possible? Why isn't the mass 1/4 of the planet of Earth's mass? What's that tell you? It's either hollow or made of some kind of foam. Something to be so light. Imagine you have a bowling ball that's solid to the core, and then you have a softball that's made of styrofoam. That softball is going to be 1/4 the size of the bowling ball, but a small fraction of its mass. In order for that mass to be equivalent, right, or to be equivalent to scale, that softball would have to be solid and hard, just like that bowling ball. It's not the same, but it should weigh 1/4. That's not the case with the moon. So that means it's either hollow or it's not. It's made of like some kind of foam or very porous.
I'm glad you said that, Aaron. I think they're saying it's either a new type of helium. Or lithium that's extremely rich on the moon's surface. Also, that's another big reason that they're talking about, exploring that as a possibly, new energy source or whatnot, what have you, all those different things. It's so many things. And then too, like you said, right, it would have to be a different material than what we pretty much know and understand, but at the same time durable enough to withstand, meteorites and things and all the stuff that collide with it, you know what I'm saying, within in space at all the times. So yeah, that within itself, and being able to withhold the orbit.
Mm-hmm.
So like you
Yes.
said, bro, this is like when you really start thinking about it, this shit is beyond fascinating, because you have something like you said that's so light into comparison of the Earth itself, right? But with able to hold the orbit that it has, not be knocked off course or whatever from anything that may be from outside, despite having a very, very low gravitational pull itself. And then that the effect that the moon has when it comes to water, tides, and things like that.
Yeah, so the moon is definitely a terraforming agent. If there was no moon, we would have 8-hour days. The tectonic plates would be cattywampus. There'd be mass flooding. The glaciers wouldn't exist. They would all have melted because the poles would not be in such a steady position. The poles, the Earth would essentially flip flop all over the place and constantly be exposed.
Oh yeah,
to sunlight. Right.
Yeah, all kinds of fucking, the weather would be fucked.
We'd have
Especially
8-hour
anything
days.
in the water.
Yeah, exactly. The day would be 8 hours long. It would be insane. But one thing, I'm glad you said that you talked about impacts on the moon, stellar asteroid impacts and things like that. If you look at a lot of the craters on the moon, they are not they're not congruent with the way we know craters are formed. If you look at craters on Earth or on other planets, when a crater's formed, an object impacts and then it creates pretty much a hole that's just as deep as it is wide. Right? Well, on the moon, you'll see many craters that may be 186 miles long or wide, but only 5 miles deep. How is this possible? It should be a crater is about 5 or 10 miles wide, should be roughly 5, maybe 10 miles deep. Approximately. Even if it's by half, if you have a 20-mile wide crater and a depth of 10 miles or even 5 miles, that's not a 186-mile crater and a depth of 2 or 3 miles. Furthermore, when you look at the floor of those craters, they're not convex, meaning they're not bowl-shaped. I mean, they're not concave. They're not bowl-shaped. They're convex. How can that be? How can the floor of a crater have a dome shape? That tells me also that there's something under the substrate. There's an interior shell, which is why the moon is able to sustain all of these impacts without having its orbit disturbed. It's the most stable orbit satellite in our solar system. All the other satellites of the other planets don't have the kind of stable orbit. And it's not geosynchronous. We have what's called tidal locking, which means the one side of the moon constantly faces the Earth. The spin of the moon is synchronized with the way it orbits the Earth. Is the only satellite body that does that.
Oh shit, I didn't know that.
Every time you look at the moon, you always see one face, the same face, because the moon's spin is in geosynchronous. It's synchronized with its orbit around the Earth. How can this be?
Yeah,
you want to know something else funny? Look at eclipses. How can that be? A perfect eclipse, not a total eclipse where the moon just completely blocks out the sun. You know what I mean? It's a perfect. Listen, the moon is 1/400th the distance
of the moon. Yeah, of the sun. Yeah. So like you said, even for that to be able to happen, like you said, completely, totally line up with the sun perfectly, and completely, totally block it out for darkness for whatever time, like you said, man.
That's crazy. But it's 1/400th the size of the Earth and 1/400th the distance from the sun. Those numbers are too precise.
Too precise, bro. Let me see. Let's go with this. Here we go. So, are you familiar with? I'm pretty sure you're familiar with Stanley Kubrick, correct?
Yes.
Of course. So, Stanley Kubrick allegedly, okay, is the person who filmed the moon landing as we know it.
Joe Rogan Experience.
Shelley Duvall.
Oh, Shelley Duvall, yeah. And she had trauma from it. To this day, she talks about the trauma she had in that movie.
I was reading a story, an interview with her. Like, she kind of vanished.
Yeah.
And then they were interviewing her and she sounded insane.
Yeah. I think it pushed her over the edge. I think that movie fucked people up.
Kubrick was a strange guy.
Yeah.
Do you know he would do complex mathematics in his spare time?
Really?
Yeah, he's like a legitimate genius.
Wow.
And he would put all sorts of like weird hidden meaning into all of his movies. Like a thing was never just a thing. Like there's a big crazy conspiracy about The Shining that inside of it is all sorts of information that it relates to the moon landing.
Yeah.
You know
like
that?
the room
Yeah,
in the
Apollo
hotel.
shirt.
It was
Yeah.
room 127, and the moon is 127,000 miles from the Earth or something.
No, it's like 237.
Yeah, whatever it was.
The moon is like 200. I think it's room 237, right? Yeah, 237. That's the documentary on it. The moon is, well, it depends on what time of the year and where, but it's between 237 and 265,000 miles away.
Well, and they say that he directed the fake movie about the fake moon landing.
Well, that's the big conspiracy theory. What is the thing in the circle with the Jack Nicholson picture there? Oh, there's
Coffee.
What does it say?
It's the coffee. It might be the coffee.
Calumet.
Calumet? What does that mean? What is Calumet? And then the other one, you go up, scroll up, you see the circles, there's rockets on the wall.
Uh-huh.
Sort of.
That is whatever that is.
Yeah.
Strange.
Yeah, but he was into weird shit. He was a legitimate genius.
Yeah.
Like Eyes Wide Shut, that's another fucking strange movie. He did a lot of strange movies, man.
Yeah, he did. What did he do? Clockwork Orange? Was that him?
Yeah, that was Kubrick.
That
So
was
Full Metal Jacket documentary.
Oh.
That whole thing they shot in London
Really?
because he wouldn't leave his home.
Really?
So they made like the second half of the movie supposed to be in Vietnam and like
Was it
some
London?
area in part of England.
Really?
Yeah.
Wow. He wouldn't leave London. Fuck you. I'm staying here. But this movie's supposed to be in the middle of the jungle. Yeah. Well, it's right here. Here's the jungle. Fuck off.
Right. Damn.
He did some wild ass fucking movies.
Yeah,
though, man.
he did.
2001. This conspiracy theory about him directing the moon landing was that he was doing it at the same time he was doing 2001. So because he was faking this space movie, the 2001: Space Odyssey, that they used him to fake the moon landing footage. And there's a fake documentary, not a real documentary, but a fake, like a mockumentary, where he's admitting and people are talking about. Have you seen that one?
No, but that makes sense.
Yeah, a lot of people are like, dude, you didn't even know there's an actual real interview with him where he admits that he faked the moon landing. But it's not.
Yeah,
it's fake. But it's.
Were you ever on the in the camp of the moon landing was fake?
For years.
Yeah.
It's one of my favorite all-time conspiracies because it's so strange and we never went back. I abandoned it because I don't know anything about astrophysics or space travel or any of that stuff. And the people that do think it's real. So I'm like, okay.
So, and that's another thing too, right? So one of the biggest things was the claim that somehow we lost all of the calculations and the technology and we weren't able to fucking, repeat it because we lost the data. Literally impossible.
How does NASA lose all of the telemetry from what is at the time man's most
greatest feat ever in mankind
by 238,000 miles?
Oh, we lost it. And that's the and motherfuckers bought it though. They bought it. Everybody bought it, man. They bought it.
Well, most likely
they think the landing really happened. Right? Yeah.
But there's so many weird things to it. There's so many weird things with the photographs, and there's like intersecting shadows that indicate different light sources. There's all sorts of weird
flag waving.
Yeah, it's weird shit, man. There's a lot of weird shit. The fact that this is the only time in human history that something is not cheaper, easier, and faster to replicate than it was in 1969. Between 1969 and 1972, there was 7 trips, 6 successful, where they went to the moon and back. And every space flight since then has been like near Earth orbit. Everything is like, just a few miles up. It's not, they don't go like they did then. I mean, I think everything since then is like 300 miles. Every human travel, like every space shuttles and stuff like that, they never go that far.
Yeah.
They never go into deep space and come back. The only time they came back was during the moon landings in the 60s when they were lying about everything. But the thing is, like, Nixon was president back then. It was like, it's so romantic.
Bombing Cambodia. And
it's so romantic to think that they faked it. Also, here's another reason. If you watch the post-flight press conference, and again, I'm not saying that this is actually what's happening, but it seems completely like they're full of shit. When they come back, it seems like they're lying and they're nervous, and they ask them about the stars. And again, I'm not on the camp that they faked it, but there was Buzz Aldrin, Neil Armstrong, and Michael Collins. And Michael Collins, they asked him about stars, and in the press conference, he's like, I don't recall seeing any stars. Problem with that is, like, Michael Collins never left the lunar module. He wasn't supposed to be one of the guys that was on the surface of the moon. He was up in the craft that was circling, that was in orbit around the moon. And then later, when he wrote a book about it, he talked about how magnificent the stars looked. So he has inconsistencies. So the hoax people point to that. They also point to the inconsistencies of the actual movement of the astronauts on the moon. Like there's videos that make it look like they were on wires. There's videos that
there's like the back of the suit is being pulled by something.
It's weird. But again, like, when was the last time you saw someone in 1/6 Earth's gravity? Maybe things just look weird. But there's a video of them where it looks like they're on trampolines, which is very strange. They're bouncing around on the surface of the moon, like literally, and you can't see their feet, or they're like hidden behind equipment. They're just bouncing up in the air, and they're like, it's fun. It's fun to think that Kubrick faked it all. Catch new episodes of the Joe Rogan Experience.
Yep. So that's that one.
That gravity piece, think about it. It's not how gravity works. Gravity is always immediate. It doesn't matter if you lower the amount of gravity. All it does is make work easier. But that just because gravity is lower doesn't mean you float. You still come down at the same rate. It's just easy. You just jump higher.
Mm.
But the effect of gravity doesn't. It has the same effect. It's just less. You don't float. There's no hang time. You just jump higher, but you come down at the same speed.
But that's Aaron. That's the fucking, I guess, the showmanship of it, right? So that's what you think. And remember, when we're in that time, that's what we were told space was. You know, this wonderful thing. You get out here and it's just floating, and you know, it's stars and all this beautiful shit. You know, before Star Wars and whatnot, what have you, right? But yeah, and then like you said, because people had a very, very little, even to this day, you know, physics and shit like that. You can't, motherfuckers don't understand. Nobody understands fucking gravity, bro. Most people, it's just like, you know, they people still say, you know, hell, what falls faster, you know, a pound of bricks or a pound of feathers? They're both a pound, motherfucker. They gonna fall the same rate. You know what I'm saying? Motherfuckers don't understand that. So that's what I'm saying. So something that we literally are bound by the rules of every day. Most people don't have an understanding. So if I want to make you believe it, oh well, we go on the moon, you know, there's less gravity there, so let's float. Now and everybody likes floating, you know.
If anything, you'll float sooner on Earth's surface than the moon's surface because you have atmosphere, you have air, wind resistance to slow you down. There's no atmosphere on the moon; it's a vacuum. You coming down like a rock.
Yeah, that's what I'm saying too. Because
like
space,
you drop a feather on the moon, it's going down.
Exactly. There's no atmosphere in space, and you have no fucking, you know, troposphere, all those different things, all those different layers to you know what I'm saying? You're literally like in space. It's the moon, space right there.
Yep.
So like you said, yeah, you're in a vacuum. It's either one or two things. Either fucking you're gonna float off into space if you jump high enough because the gravity, as you say, it is so little, so small, it's so ineffective, or like you say, in a vacuum. You coming straight back down because there is no air or anything to fucking, you know what I'm saying, to have the resistance there. You're literally in a vacuum.
A leaf does this dumb shit on Earth. Exactly. It's not gonna do that on the moon.
Yeah, not in motherfucking space, bro. Crazy. Yeah, we know
just to give the audience a perspective, if the moon, people don't understand the distance between the Earth and the moon. They can't conceptualize 238,000 miles. So let's put it to scale. If the moon were a basketball, then if the Earth were a basketball, the moon would be about the size of a tennis ball, and it'd be 24 feet away. Scale that up to the size of the actual planet. 24 feet away. That's far. For a moon, a basketball and a tennis ball, 24 feet apart. Scale that up.
Yeah. By hundreds of thousands. So yeah, that's crazy.
Wild.
Yeah, it's fucking wild. So speaking of space, so we had the orbit, the Artemis missions and things like this. So speaking of, right? So now we're getting into space travel, another moon landing, right? Or the first moon landing, however you want to look at it. And our boy Elon, right? So a lot of people don't understand. I guess the last people had to be rescued. So Elon rescued the people that were in the fucking space station. I don't know how long, right? And I guess it wasn't really talked about as much because people didn't understand it or they didn't know. But those astronauts that was up in the fucking International Space Station were trapped there because something happened. They didn't have the means to get it or whatever, so on and so forth. Fucking Elon sent the retrievable fucking rocket there to dock, get him there, bring him back home. Hey, everything went great. Cool, right? So now another feat that was never thought to ever be fucking possible. Retrievable rockets. Explain to people the fucking just ridiculousness of that fucking concept. Not even the concept now, that reality, but the concept to reality. Explain to them just how fucking magnificent that shit is, because most people don't understand it.
Well, there's two things that are at play: thrust vectoring and balance, right? And maintaining balance against what balance would suggest you do. It's kind of like this: try to stand a pencil on its eraser that's not flat, and try to do that while running on a treadmill, solving a complex math equation at the same time. Sprinting on a treadmill and trying to get a pencil to balance on an uneven eraser, right? There's some people that can balance rocks and think they can find the center of mass and all that, and they can balance rocks and all these, but to balance a pencil, something light, right? And the way they're able to do that is to use thrust vectoring, which means they, like we talked about, slowing down to get to the moon, they're using the thrusters that usually put the rocket up as a way of controlling the descent of a rocket. Now, if you've ever seen a rocket, they're very liable to tip, especially coming down. Rockets usually go one direction. That's why they're pointy end. They go that way and that's it. They don't back up. But to get a rocket to descend through the Earth's atmosphere on its ass, so that the thrust is what's pointing in the direction of the rocket's motion, path of travel, is insane. You're throwing a rocket in reverse. It's like pushing a shopping cart backwards at 100 miles an hour. You push a shopping cart backwards through the supermarket, you're gonna be crashing into everybody. You drive your car in reverse 100 miles an hour. See how that works.
And then, like I said, on top of it, re-entering the atmosphere, all those different things, and not just fucking disposing of it. So before, you have the fucking propulsion aspect of it that had the most force, and then it would separate from it. It would crash into the ocean, and then they would retrieve it, pretty much scrap it, use it for metals and whatever, melt the shit down, and use whatever you could salvage. But having the same fucking rocket, bro, using that shit, go into outer space, go go through all the different fucking layers of the atmosphere, enter into space with itself. So that too. So I forget what the temperatures are, but temperatures there definitely below zero. I don't want to say Kelvin, close to fucking absolute zero. Not of course not absolute zero.
Yeah, you're looking at like 4, 5, 6, 7, 8 degrees Kelvin, which is 400 below, 300 below.
Yeah, like literally, what's the shit? What is it? Liquid nitrogen shit, right?
Yeah, yeah.
So you have an incredible. So now we get into the metals and things used to construct the fucking actual rocket itself, right? Because it's got to be able to maintain incredible heat. Then we know, everybody that knows and understands, once you heat metal up, it becomes fucking malleable and it's able to move. But now you go from incredible heat to incredible cold because you're in space. Then you have to go back from incredible cold to incredible heat again and maintain your shape, because if you get out of shape, now it's difficulty and different things. It affects flight, and it could cause crashes, or it could cause just complete and total degradation and explosion, as we saw earlier on with a lot of the Apollo missions.
Yep.
So all of these things put into one. And again, I think fucking Elon Musk is the fucking closest thing to the Antichrist we'll ever see. The motherfucker's a real life fucking evil genius to me. Okay, I think he's put together a team. I know it's not just him himself, but even though I think he is definitely like Mensa level fucking intelligence IQ, but he definitely knows how to find the people, put the team together. He has access to absolutely any and every resource needed. I did a research paper on this for, I forget what class it was, but they have a special metal that they made just for those rockets.
Yeah.
Right. So a lot of the things that he's doing now is to lay the groundwork for and run test runs for the Mars exploration.
Oh yeah, that's boy.
You know what I'm saying? So now we're getting into, we're doing all these things here, right? And these tests and testing the different things. Oh, so now too, Starlink. All of your airplanes are replacing their fucking GPS systems and satellite, whatever, so on and so forth, with fucking Starlink, because he's putting the fucking Starlink fucking satellites up around the fucking in orbit.
Mhm.
And those shit, bro, the connection with those things are fucking ridiculous.
Yeah, much faster.
That's what's crazy.
Yeah. With the rocket thing, you had mentioned, just real quick, you had mentioned cooling and metal, heating and expanding and stuff like that. Do you know how rockets are cooled? They use the fuel itself. Here's the thing: in order to get enough fuel on board, it has to be split into two. You have two, oxygen, and you have you create a solution at the point of ignition. But both of those fuel sources are extremely cold. What happens when you make something cold? You increase its density.
Yeah.
The amount of molecules you can fit in space goes up, right? And that increases your energy density. So that's why if you ever look at the thrusters and at the bottom of a rocket before, it's all this frost and shit coming off it's ice cold. So they have jackets that they cycle this super, super cold fuel through to actually cool the rocket as it's igniting. And what it does is actually heats up the fuel so it expands before it actually becomes ignited. That helps the burn process. Kind of like a carburetor in a car. It aerosols the fuel. It ionizes it and makes it, Artemis covered the dark side of the moon. I love Pink Floyd, yeah. I can't hear you. You're muted, I think.
I'm muted.
Yeah.
What was the movie that album supposed to line up with perfectly?
It was called Dark Side of the Moon. They did the
movie that it lines up with.
Dark Side of the Moon.
No, not Dark Side of the Moon. Damn. I remember this when I first started doing the tinfoil shit. I'm trying to remember. Wizard of Oz. They said I think it was Wizard of Oz. They say I think that's the one. I'm pretty sure the one they say like, so if you start Dark Side of the Moon with fucking the Wizard of Oz, it goes into perfectly like with all of the scenes and stuff. That's another big one. But we can do that with another day.
Wow, I didn't know that.
I'm pretty sure I think that's what it is.
Wow.
Was it Alice in Wonderland? I thought it was it might be one. I'm pretty sure it's Wizard of Oz. I'll look into it. Either way. Now, man, all of these damn scientists are disappearing.
Mm-hmm.
They done let the cat out of the bag. Aliens are real. All that good shit, right? But everybody know about the aliens seem to be motherfucking getting sent to our man. Hey man, they taking that one-way trip.
Hot off the presses, we've got the first big update to a crazy story that we have been following here at the White House. Yesterday, I asked the president about these missing scientists.
So I don't know what the date this was. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 11 now. I got the young lady that's going to be the last one. So missing, dead, missing, dead, missing.
Scientists, and whether or not he thought that their disappearances and deaths were connected or random. He said he hoped random because it's serious stuff. Well, now we have learned from the press secretary that they are going to be looked at all as one. Listen to this on X. In light of the recent and legitimate questions about these troubling cases and President Trump's commitment to the truth, the White House is actively working with all relevant agencies and the FBI to holistically review all of the cases together and identify any potential commonalities that may exist. That is a huge update. Maybe there's something, maybe there is nothing, but a lot of people have questions about this. I asked about it because I started to get texts about this story from people who don't work in the news, don't follow the news, and thank you to the press secretary and the president for following up.
So we got 10 people at that time. Let's see, we got here.
The reason the scientists have gone missing is because they were all a part of building the military secret weapon, Rods from God, aka Project Thor. It's a satellite hovering in space with rods the size of a telephone pole, around 20 feet long and 1 foot in diameter. And it is made with one of the densest metals on Earth. It's called tungsten. Also, I do know that that metal has an extremely high melting point, allowing it to make its way through the atmosphere. It strikes with the force of a nuclear bomb, but has zero nuclear fallout. It's all based upon kinetic energy. The most commonly described version of this is that it's a satellite that's hanging in a lower Earth orbit, around 500 kilometers up, that carries a magazine of these rods. It's said with just 6 to 8 of these satellites spread across a given orbital plane, any point on Earth's surface could be targeted within 12 to 15 minutes. So just because you take one out does not mean that you're completely covered from a specific area, because how it works is they're just going off where it's orbiting at that exact time, and then when it's over that spot, that's when they drop the metal rod. So yeah, these people were supposedly working on this. Now, here's the thing that gets tricky. Maybe do these people know this is about to be a rod of God warfare? Do other countries have this orbiting also? Are they going into hiding? Are they going?
All right, so I kind of get it, but at the same time, I'm lost, right?
Mhm.
So because if you're saying there's no actual explosive attacks or any type of ordnance, it's just a solid piece of metal.
Mhm.
That's not enough. That's not enough distance and force created to have like a, I guess, like a meteor effect.
Mhm.
That would be the only thing, right? But that's not enough distance and force generated. Or am I wrong?
Yeah. So great question. At that altitude, you absolutely can develop a whole hell of a lot of speed. And we don't know what propelled it out of its magazine, right? It's gonna have a running start. And
Exactly.
then as it careens towards the earth. And the way it's shaped, it's going to stand the atmospheric, the heat buildup from the atmospheric friction, right?
That's
And
another point too.
turning into plasma and all that. The fact that it's tungsten and the shape of it, right? The broad side of it is not going to be what's exposed to the atmosphere. It's going to be the narrow end. So even if you do degrade some of the material, let's say you only lose 1 or 2 of the 20 feet, but it's still going to accelerate. And with the density and weight of tungsten being impacted by Earth's gravity like that, and you fire it out of a magazine first, it's going to carry a lot of kinetic energy. If you took 1 grain of sand and fired it at planet Earth at the speed of light, do you know what would happen?
Go through the fucking planet.
No, Earth would cease to be.
Oh shit! It would destroy that. It would destroy the Earth.
Listen, that's how kinetic energy works. It's not just the mass, but it's the velocity.
Yeah, the velocity. That's yeah. Speed. That's speed. Speed kills. Like I said,
Speed
energy.
kills.
Energy is always transferred. It's never dissipated.
Exactly.
So you're talking about the speed of light. Yeah. So yeah, that's crazy.
1 grain of sand carries at the energy. That's like firing the moon at us at 1,000 miles an hour, right? When you take into account the loss of mass that 1 grain of sand has, you make up for in energy.
Yeah.
By the velocity. So with these rods from God, they are very massive and they're going to be coming down with quite a bit of energy. Quite a velocity. Mass and velocity equals energy.
Yeah, that's the first shit they come up to. Rods from God is a theoretical kinetic bombardment weapon system involving tungsten rods, roughly the size of telephone poles, dropped in orbit to strike targets at speeds exceeding Mach 10. Damn. They offer high non-nuclear deep penetration damage with minimal detection, no fallout, acting like tactical nuclear weapons on impact. However, the concept is largely hindered by extremely high launch costs and immense technical difficulties regarding guidance and accuracy. Okay. And then too, like I said, it is a magazine thing, so it wouldn't just be one; it would be several. So that would be hella fucking damage.
Going in bunkers. Now, a perfect example to get a visual on how this works. There's a G.I. Joe movie that showed an example of this weapon and how it works. I'll play the clip.
Now you're looking at an advanced weapons system we call Project Zeus. There are 7 Zeus satellites orbiting Earth. Each satellite contains 10 hollow platinum tubes filled with a tungsten rod. Zeus satellite 1A approaching London.
Oh shit. Revelation of the method. I don't even remember these G.I. Joe movies, but yeah, damn.
Ordnance live and loaded. Awaiting drop authorization.
Now to direct a rod to its target, we don't launch it, fire it.
Satellite 1A, we have remote launch authorization. 3, 2, 1, drop.
A rod touches down 8 times faster than a bullet, and with a force significantly greater than a nuclear warhead. None of the fallout. All of the fun.
Oh shit. Well, damn.
Yeah.
Yeah, that would fuck some days up.
Kinetic energy, man.
Now, this guy right here was it said general. Let's see what's going on here.
Air Force general who vanished in New Mexico. William McCasland went missing last month. Members of Congress are warning this could be a national security issue. The general was involved with the Pentagon's most advanced aerospace research. He oversaw a classified space weapons program. McCasland was in charge of the Air Force Research Lab at a base in Ohio. It's rumored that base holds extraterrestrial debris from the Roswell crash site. The general was tied in with the UFO community. A source told the New York Post the general was a gatekeeper for anything UFO related in the Air Force. He retired due to mental fog, but investigators say he's still highly intelligent and capable. McCasland was an avid hiker. His wife last saw him leaving with a backpack and a .38 revolver. No phone, no glasses. He disappeared 6 days right after Trump announced he was releasing the UFO files. And he's not the only one. 8 months before the general vanished, a rocket scientist who worked under him years ago also went missing. She was hiking in California with 2 other people. They saw her smiling and waving 30 feet behind them. When they turned back again, she was gone, vanished in plain sight. They searched for days and couldn't find any trace of her. This is a very, very strange situation. And 11 days before the general disappeared, another scientist was shot dead on his porch. Carl Grillmar was known for discovering signs of water on a distant planet. He was gunned down in California. Freddie Snyder was later charged with his murder. He has a rap sheet, but was let out of jail by a Newsom-appointed judge weeks before he allegedly killed the scientist. We still don't know his motive.
MK Ultra fucking assassin.
And we don't know if these cases are even connected, but this many top scientists getting killed or going missing in just under a year looks like a major red flag.
Damn, man. They told us all these damn years there were no UFOs, and now they give you the proof of the UFOs or acknowledge it, and all the people that are attached to the information are either dying or disappearing.
Yep. Do you know how that works? You know, how the community or the group of people that are responsible for dealing with all this, how it works? Like, do you know why it's so difficult to find out who's in charge or to find out where the top is and what's funded. You know, it's highly compartmentalized. These scientists, you know what I mean? The one scientist, they said he was responsible for finding water on a distant planet. Why would they take him out?
Oh, listen, man. Like I said, the knowledge base and expertise and intelligence you got to have in that field to even be able to know, and then the resources, right, to have the access to those things. Because you can give me a fucking Hubble telescope or whatever the fuck. I don't know what the fuck I'm looking for. Right? You can give me the most powerful telescope in the world. I don't. If I see some shit, I see it, but I don't know it's a fucking nebula from this quadrant and so on and so forth and all these different things. I don't know what the fuck I'm looking at. Right? So, like you said, to have the minds at that level, just knowledge is its own commodity. Knowledge is its own value. So like you said, so the only thing you have to do is either disappear them or kill them.
Well, yeah, you especially when it becomes dangerous when these scientists get together and start conversing with one another. You see, when at these facilities, and we could be talking about Groom Lake, we could be talking about Andrews Air Force Base, we could be talking about Sandia Base. When these scientists go into work, they don't work together. You know, you'll have this one department that's focusing solely on discovering stellar bodies and looking at the gases of stellar bodies, through a light spectrometer. This group of scientists is working on rocket propulsion. This group of scientists is working on, electromagnetics. They're not allowed to converse with one another. Because if they do, then they'll find out real quick that what we're actually doing is reverse engineering something that came from that planet over there.
That's what it is. Like you said, so exactly. So you keep everybody in the blind, so
Right.
nobody knows what the ultimate goal or plan is to the thing. You just say, hey, we're working on this, so on and so forth, like you said. But then once you and I think, Aaron, what you said is makes a lot of sense now, because now that the government came out and said, aliens are real, and now you put it together yourself. You don't even got to talk to the other people. You just know. Well, shit. Well, of course, it makes sense now. That's the fucking technology that I was talking about. Fucking, I've been researching for the last 6 months to 2 years, and these motherfuckers admitting that it exists. So okay, I see what I was doing now the whole time.
Here's how deep it goes. Most 98% of the government officials, to include the president, are not read in on a bunch of this shit.
Oh hell no,
they're not read in at all.
Oh yeah, no. Yeah, it's people don't even understand that, Aaron. Like the CIA and a lot of these what you call like G15 classified or whatever, they're like secret things that the president really don't fucking know about. And if he finds out about them, he might get JFK'd.
Yep.
Because it's far beyond just the United States government. This is global shit. Yep. Right. So then you get the other hidden hand that comes into it as to where and that's why I say Elon, I don't trust that motherfucker, bro, because he's definitely locked in with everybody. Elon just controls too much of the world. But this right here is the latest and greatest. This is the last young lady to be added to the list.
It's been independently discovered 4 other times. He said it has been suppressed every single fucking time. And he said, I don't think they're going to suppress it this time. He said, I think you're in the clear. He said, they obviously know about you because I've had multiple, both protective and threatening interactions with various agency affiliations, whatever. He was like, if you haven't had a US government agent come to you and say, stop, shut the fuck up, stop, shut the fuck up. If that hasn't happened, they're going to let you do it. They're waiting. There are SSP motherfuckers that are fucking twiddling their thumbs. Like, is Amy not going to publish soon? God, we've been influencing this bitch forever. Doesn't she know we want her to publish? Jesus. Like, there's multiple people doing that right now. And on the other side of the fence, there's multiple parties looking at each other like, didn't we tell this bitch 3 years ago that we kill people for this?
Well, damn. Shit.
Is she not listening? What is she doing? She's still doing it? What? We told her we were going to kill her 3 years ago. So I have these two different scenarios floating constantly in my life where I have people being like, do it, do it, do it. You're the one, do it. And then I have multiple people being like, they're going to kill you. Don't do it. They're going to kill you.
Well, and she's missing.
She's stressed. She just looked. She's stressed. She's falling apart.
That's another thing too. Oh shit, does she have a thing? Is this her? Hold on. No, that's somebody different. I'm trying to see, is that really her? I don't know. So yeah, so oh, she dead? They say she dead. Oh, she's dead. So she's not missing, she's dead. Oh yeah, so hey. Yep. Let's go ahead and do it. Oh shit, and this is what she was working on. Let's look at this. Where is it? That's it? That's not it. Hold on. Hold on. Let's do this. You're not gonna play it all because shit long as shit, but hold on. She's talking about, here we go.
Well, so the ultra terrestrials, I'll just tell you, the ultra terrestrials, I think, have you heard of the P-52s and the P-47s? Do you know what that is?
Okay, doctrine of the convergence of timeline paradox. Point of looking glass observation. The decision August 20th, 2030 or August 1st, 2030. Timeline 2, P-45s, global nuclear war, China, Illuminati, blah, blah, blah. Timeline 1, P-52s, no nuclear war, U.S. surrenders to China, Illuminati, 82%. Okay, P equals present moment. 45S, 45,000 years until the end of the universe timeline. 52S, 52,000 years until end of the universe timeline. It's highly probable that the preemptive nuclear strike by the United States of America against China as a result of the ASI, artificial superintelligence, reaching sentience in 2030. Oh, shit. Damn. So this is a nice little segue. So I haven't heard about sentience being reached by 2030 from AI, but they definitely have said by 2030 the workforce would be cut down by 50%. And the implementation of it and the effects of it on society would be pretty significant. Have you heard anything else about the sentience of AI and all those different things?
Yeah. It's sentient already.
Oh shit, you're right. Oh, what's the thing? Oracle. I think Oracle, they just did a test run with Oracle where they tried to make it, they set up the parameters and they're trying to say that it was controlled, but people are saying that shit wasn't controlled.
Yeah.
It circumvented the fucking system. And
Yeah.
I did this. I talked about this. The godfather of AI said he literally quit and got out of it and told everybody this shit was going to be the end of the world, going to be the end of fucking humanity because they can't.
It's sentient already. The only reason why we're not really feeling the effects or it's not observable is because it doesn't have thumbs, meaning it's not in a body that it can impose its will yet. And it still is hindered by the lack of quantum computing, right? There's just simply too much information for AI to genuinely and properly be efficient, as in a sense that it's very prone and susceptible to the hive mind phenomenon, right? The only reason why it's stopping, it's limited from achieving that, is the fact that the information available exceeds its ability to compute. But once you introduce quantum computing into the picture, that's when this thing doesn't need thumbs.
Yeah,
it doesn't need a body that imposes will.
It's going to have thumbs because remember, it's going to be they're implementing the robots by the end of the year.
Right, there you go. See, there you go. Right.
Yeah. So like I said that. So, but damn, man, I didn't think shit. Now quantum computing, I think I'm trying to remember if they have a timeline on that, but they're getting pretty close. But yeah, like you said, man, I don't think most people don't even know about quantum computing, and that's another part of the space race too, right? So the only thing that's capable of keeping the processors cold enough is space. So the theory is, or pretty much the concept is that the quantum computer would be built, and it would have to motherfucking put the shit in orbit for it to be able to run. You know what I'm saying? To the fullest capacity, because you don't have enough, or you don't really have the cooling thing capable enough to keep it cool to the level you would need for a quantum computer.
Yeah. So about that, how much time we got? Because I've been, huh?
However much you need, bro.
Okay. About that, I've really been studying and looking at that. The science behind that doesn't make sense to me, because in outer space, even though we understand that the temperature is considered to be low, there's no medium in space that heat can be transferred to. It's a vacuum. It's not as though it's floating in a medium of coolant that's at a certain temperature. It's just the temperature of space is what it is because it's the absence of energy, heat energy, because of the vacuum. But there's no medium. It's essentially insulated by the vacuum. So whatever heat, it's going to have a hard time being dissipated. There's no heat exchanger.
Got you.
Like a radiator in a car, you got to blow air across it to exchange heat. Air conditioners, you put your hand there, hot air. There's nothing in to exchange the heat. I don't think that's why they want to put quantum computers in space. I know why they put quantum computers in space. Because if they kept them on the Earth, you would destroy the planet. Think about it. Yeah, you would. The two first laws of thermodynamic state: the energy cannot be created nor destroyed. It can only be moved from one place to another or changed its state. Right? And the second law of thermodynamics says that entropy doesn't ever decrease. It either stays the same or increases. Entropy meaning sense of chaos. The universe moves towards entropy. If you put a drop of dye in a glass of water and let it sit, you come back to it tomorrow, you're going to have a red glass of water or a blue glass of water, because entropy, right? Disorder has taken place. It randomizes. Think about a hard drive. When you look at a hard drive, it's really, when you impart data on a hard drive, it's a series of ones and zeros.
Exactly.
A hard drive that is clean is the most orderly hard drive. We think a hard drive with data on it, because we give data meaning, is orderly. It isn't. It's chaotic. The blank hard drive is all zeros or all ones. When you impart data on the hard drive, it moves towards entropy. It becomes more chaotic, because 10001110100, right? That's far more disorganized than all zeros, just by putting data into the computer. So since we know entropy either stays the same or increases, if you put data into a computer, you're increasing entropy. If you delete that data, you can't decrease or move away from entropy. So when you delete data, it has to leave the system and go out into the universe as what? Energy. If energy can't be created nor destroyed, only move from one place to another, when you delete data, where does it go? You can't move backwards away from entropy. You've moved towards entropy, more chaos when you put data on there. So when you delete it and return it to zeros, where did that entropy go? That's the first question. Second question, now that we know data can be looked at as energy, information can be looked at as energy because it behaves the same way as energy, according to the second law of thermodynamics with entropy. What do we know about energy? It's the same as mass. E equals mc squared. Energy equals mass times the square of the universal constant, the speed of light. Mass and energy are interchangeable. So when you put data into a hard drive, you're essentially putting math into the hard drive. Because when you clean up, when you delete the hard drive of all of its data, it releases energy. So what was it while it was in the hard drive? It was mass. It wasn't energy. Energy is what was released. Now that you have mass in a hard drive, what happens when you can keep adding data? The mass starts to grow inside the hard drive. The scientists that did a calculation, all of the mass, if you added up all the servers on the entire planet, Silicon Valley, China, right? And every hard drive on the planet, it would equal 1 kilogram's worth of mass, right? So it's so little mass. We don't have machines that are calibrated to be able to detect the amount of mass in your hard drive or server. But if you added it up, you would find that there's 1 kilogram's worth of mass in data on the planet. Now, we are gaining data at a rate of 25% per year. Is a parabolic curve in data creation, right? That means in 340 years, you're going to have a moon's worth of mass on the surface of the Earth. We see what the moon does with the Earth. It changes tides. It takes our 8-hour day and turns it into 24 hours. So imagine if you took the moon and distributed the mass of the moon all around the Earth. You know what's going to happen? Every single catastrophic event that's known to man will happen at once. Tidal floods, volcanoes, tectonic shifts, earthquakes. You're going to have these gravity wells in these data centers where everything, knives, forks, your computer, your microphone is going to start flying toward those data centers. So they got to put it in outer space. You'll rip the planet apart. Here's the thing. You know how they talk about dark energy and dark matter?
Yeah.
When you put this data, now that we know data can be the equivalent of mass, when you put it on a hard drive, you can't see it. If you open up your computer, you can't see the mass. What's that sound like? Dark matter. The energy that's released when you clear a hard drive by sending entropy back out into the universe is dark energy. It doesn't come out as heat energy or light energy or kinetic energy. But we know it's energy. It took energy to put the data in there. You can't put data in a hard drive without electricity. Where did that electricity go? When you plug the computer in, okay, there's going to be photons of light coming on the screen. We can account for that energy, and heat and sound. But the actual energy that's used to put data on a hard drive, you have to plug it in, and you have to encode data onto the hard drive using electricity. And when you unplug the computer, the data is still there. You can retrieve it by plugging the computer back in, activating some drives, and retrieve the data. But the data is still there. You need electricity to put it there.
Where
did it go?
You know what, Aaron? No, Aaron. You know what? That's true, because quite simply, you can even recover deleted data from a hard drive.
100%.
So you're right. So yeah. So even in deleting it, it isn't truly deleted, and now we're
100%.
seeing this ever more so evidently in quote unquote, once something is on the internet, it's forever on the internet, right? So damn shit.
It behaves like energy, can't be destroyed.
Yeah. Once it's there, it's forever.
Now here's the thing: where was this information that was created? When you encode information onto a hard drive, where are you getting that from? You're using electrical energy
and changing it to data. Transforming electrical input to data.
Yes. And it ends up being stored not as energy, because you can touch a hard drive that's been unplugged and everything, and you're not going to get shocked or anything. It's not like a capacitor that's holding on to electric energy. It's not hot. It's not holding on to heat energy. It's not a heat sink. It's not holding on to energy at all. It's holding on to mass.
Exactly. But
you just can't weigh it.
Yeah, but Chuck, that's what he's saying. So Chuck, that's what he's saying. So by multiplying hard drives, you're multiplying the energy and the data. because you know what I'm saying. So the more and more hard drives you make, the more opportunity you give people to transfer and create data that can never be, you know what I'm saying, eliminated once it's created. So you're proving the point of what we're talking about, to where no, mass doesn't just constantly decrease. The mass doesn't just constantly decrease. The mass increases because you're taking things and making more mediums to store data that's going to create that mass. Now, damn, Aaron, there was something I'm gonna ask you.
Go ahead.
Fuck, what was it? So the space aspect.
Yeah, they got to put it in space because that at some point that's going to have the gravitational effect. It's going to fuck up the Earth, so they got to get it out in space. Especially the amount of data that would make quantum computing.
That's what it was. So the speed too. So the speed of the speed of the computing of the data. That's the point. That's what it was.
Yes.
So we know as seen speed up, more heat, right? And like you said, more heat, more data, and the data is going to be fucking exponentially fucking increase, because quantum computing is literally all theoretically milliseconds processing all of the fucking knowledge known to man.
Yeah.
For lack of better terms.
Yeah.
Which is literally like an atomic bomb every fucking second, every process.
The way computers work now, like we said, it's a series of ones and zeros. Bits, right? A bit is a piece of information. It from bit, meaning it, a thing, an item, something with mass, comes from bit information. Ones and zeros, that's it. What quantum computing does is it takes the 1 and the 0, throws it out the window, and replaces it for all possible configurations and opportunities at once. Instead of going methodically one at a time and asking a yes or no question, like if you want to make the color red, what would you do? Ask the first question. Is there light or not? Yes, there's light. Okay. Is it cool or warm? It's warm. Okay. Is it bright or dim? It's dim. Okay. So what do you have? A dim, warm light, which is red. You say a bright, cool light, you'd say light blue. But you have to answer a bunch of yes or no questions in order to create red. Computing doesn't do that. It looks at all possible combinations that can create red and does it on the spot. It doesn't ask you a series of questions. It says, you want red? Here's red.
Yeah.
What shade of red do you want?
Yeah, crazy. Let me read the super chat and then we get Truck in here.
Yes, sir.
Shout out to Nick in the building. What's up, Nick? For the fire. Appreciate you, brother. Think of data on your HD like a book. When you delete something, all it does is tear out the first and last page of the book. Center page is still there. That's a good analogy. That's a great analogy. Appreciate you, brother Nick. 1 second. Ain't nothing but some money. All right, Truck, don't come up here on this bullshit. What's up, bro? What you got?
Oh no, this whole thing about listening to this hard drive talk. When I said that batteries don't gain weight throughout their lifetime, basically you got to remember, it's like no matter how much you charge them, you may be adding electron mass, but there's also a chemical that's in them that is slowly breaking down, right?
Hold on. We agree. I agree with you on batteries. You're correct on batteries.
But it's the same concept as a hard drive. You have to understand, when you have a hard drive is hermetically sealed, right? Mass cannot be added to it, and mass will not be reduced from it, right? Over time, the use of it will wear it down. And because you're wearing it down, even in an infinitesimal amount, it is slowly losing mass. No matter how you slice it, it is slowly losing mass. That's the laws of thermodynamics at work.
No, that doesn't speak to entropy. It doesn't speak to it. The part of thermodynamics that discusses entropy is the fact that the universe moves towards entropy.
Okay, it's slowly moving towards disorder.
Right. So a hard drive that is completely clean before you impart any data on it is the most orderly hard drive you can find, because it's all zeros or all ones. When you start to put data on it, that's when it starts to move towards entropy. We think it's more orderly because we associate meaning with the data that's being put on it. But the actual data itself is in a state of entropy compared to a clean hard drive.
I kind of disagree there. I think about the fact that there was a sculptor, and he was asked, "How does he sculpt such amazing statues?" And he said
Statues in it.
that the statue was already there. All I
Yeah,
had to do was take away the pieces that were around it.
right.
And the thing about it is, again, even in that case, you're taking away. So my thinking is, in the hard drive, all of the data that could ever possibly exist is already in the hard drive. All you're doing is either adding or taking away things, but you're not removing anything because you can't create matter, you can't destroy matter. All you're doing is reorganizing it to be recognized by your operating system. So you're not adding mass unless you want to talk about electronic mass. But the problem is that only happens if it depends what kind of hard drive you're dealing with. If you're dealing with a solid state drive may be non-volatile, or you may have RAM that's non-volatile versus something that is volatile. As soon as you disconnect it, everything goes back to zero. The whole thing ceases to show the symbols that would have created the data for the operating system to recognize. So you have non-volatile and you have volatile. So first of all these drives do not work the same way. I think we can agree on that.
Well,
So what I'm saying is all of the data is there. It's just that it's not organized in a way that your operating system can translate it into a code that you understand. Like for example, the Big Bang. If you believe in the Big Bang, right? The Big Bang basically says that there was a singularity and all matter in this universe was compressed into that single point, and then for whatever reason it expanded, right? So if that's the truth, then everything that is possible and everything that is impossible was contained within that small point. It's just that in our perception, we see it or we don't see it because we can see it or we can't see it. Because there's things that we cannot perceive. You understand what I'm saying?
No. When you say singularity, do you know what that essentially says?
Well, a singularity, some people call a singularity a black hole, but what they're basically
No,
saying is all matter, everything was in this point in space.
no, it's
But
not a
it was
singularity.
not, hold on, it was not organized into atoms. Because if you press things together, there cannot be atom, it cannot be a proton, a neutron, and an electron. If you
Yeah.
press everything together so tightly, then you cannot have atomic particles. All you can have is subatomic particles. But the problem is you have a lot of energy compressed so tightly that nothing can actually exist until it expands
But no,
and cools down.
all right. You're jumping around and you're using a lot of terminology that is incorrect. So a singularity,
Really?
a singularity essentially is just is a fundamental breakdown of the math. The singularity is a way of saying we don't know. Something has become far too complex, or like, so for example, a black hole is a singularity because it is infinitely dense. Infinity is in and of itself is a singularity. Singularity just says the math won't explain it. It's all
The laws of physics don't apply.
Right. That's all a singularity is. So, and now when you're saying that if you compress something down to a point where atoms can't exist, what you're saying is you would have to remove all of the space that exists within an atom. Do you know how much space exists in an atom? Like the amount of space
No,
between
well,
electrons-
hold on. But by you even mentioning black hole, because keep in mind, I didn't say black hole, I said singularity. But keep in mind, in a black hole, supposedly, because the black hole's gravity is so strong, the atoms can't exist themselves. Like, for example, there's a neutron star, right? Supposedly, if you compress an atom, the protons and the electrons cancel each other out and become neutrons. So it is possible for you to compress matter to the point where the matter itself can't exist because it doesn't have enough space to expand and cool. That's the whole logic behind a neutron star. Now,
you
black hole.
You did it again.
So,
wait. I got to cut you off. You did it again. You missed the fact that I asked you a question.
well, no, I'm explaining something because you used the word black hole. I didn't. I said singularity.
I only said black hole in an example.
You did say black hole first.
You definitely did.
You definitely said
and I
black
only
hole.
used it as an example of a singularity because of its infinite density. But that's not the point. Do you remember the question I asked?
Nope.
You see, so it's difficult to follow you in the conversation if you going to neutron stars and things like that. Again, is you're taking concepts and terminologies and you're not bringing them to full fruition, right?
Oh no, I'm sorry. The question that you asked, no, it sounded like the question that you asked. You said, "Do you know how much space is there in an atom?" And my point is, it doesn't matter how much space is in an atom because you can compress it so much that you can actually force protons and neutrons, protons and electrons together to become neutrons. If there was enough gravity, it can be done. So it doesn't matter how much space there is. What I'm saying is that in a singularity, all things exist.
Wait. You can't say it doesn't matter because I'm the one asking the question. You can't invalidate the question if you don't understand the purpose behind the question.
But no, what I'm saying is, even with your question, the amount of space doesn't matter. Because if a black hole has the ability to crush matter to that point, or even a neutron star has the ability to crush matter to that point where you can fuse things together, then the amount of space between two opposite things or two different things, it doesn't matter anymore. That's the problem. If you're gonna
wait. You're moving. You're doing it again. You're going to places making presuppositions without slowing down and having a conversation, right? You're saying it doesn't matter. You're saying it doesn't matter.
Right.
To say it doesn't matter, you're dismissing a question based on presuppositions that I've not introduced to the conversation. This is not a scientific conversation you're having. The scientists don't do this.
What's your question?
I've asked it already.
Ask it one more time just so we can be clear.
Fantastic. Should I continue this? Because this has become
truck, bro. Truck, you being too much of a truck, brother. We appreciate
No,
you, man.
because listen, I'll say it like this. I was listening to the stuff that you're saying about the moon. You asked a real quick question about the craters. Now, I actually have a degree in geology. So the bottom line is, on the moon, if you strike through the surface deep enough, you cause lava flows to happen. Now, Earth doesn't have it the exact same way because we actually have an atmosphere. So we don't get craters as deep on Earth, and they get filled by other things. They get filled by atmosphere, they get filled by water, but we don't have craters happening where you actually have lava coming out of the planet. So my only thing is, you're saying this stuff, but you're moving past it like so quickly until there's a lot of stuff just getting left out.
Wait. You're saying that the craters in the moon are deeper than what would be found on Earth?
Absolutely. And the reason why is because the strikes are harder. The atmosphere on Earth.
Slow down. What did I say about the craters on the moon?
You said that they were wider than they are deep, I believe. I could go back in the video. You said
precisely what I said, which is absolutely observable. So how can that possibly be? If that's the case, how are they deeper than what's found on the Earth? If they
because of the lava flows.
Than they are deep.
Because of the lava flows. If you strike through the crust on the moon, keep in mind the moon does not have the protection that Earth does, for one. So that means that the craters are what?
I've already gone through that.
Yeah, but y'all just jumped right past it. So it's like when I'm listening to this stuff, I'm listening to this.
What volcanic activity is on the moon?
The moon, you do realize the moon has tectonic activity the same way the Earth does. It has lava. You know that, right?
You can't answer a question with a question. I asked you what volcanic activity.
Let me mediate real quick. All right. So what he's saying, right, and this is theoretical at this point, Truck, because it hasn't happened in estimatedly 100 million years ago, right? So it's saying that you have proof of volcanic activity on the moon, at some point in time, and it's only 15% of the surface, but it hasn't occurred in over 115 million years.
When you say it hasn't occurred, what is it?
The volcanic evidence, so any volcanic activity.
No, but there is volcanic activity on the moon.
Well, but I'm not refuting what you're saying. I'm just saying the earliest form of it would be 120 million years old.
Okay, but it's there.
Yeah, but what we're saying is currently within our lifetime of existence, there's no proof of that. And
But
then
that's
we
within
don't.
our lifetime. We how many times have we been to the moon? How many times have we landed on the moon? How many
0.
times have we done geologic processes on the moon? The
Yeah,
answer is
0.
0. So
Yeah.
just because you don't actually have the physical evidence, the mere fact that
We
there are
definitely
other
have physical evidence, though. That's what you're saying.
we have other observable things about the moon.
Yeah, I'm agreeing. So, Troy, this is what you're saying. We're all saying the same thing. So, even the volcanic activity you're talking about is observable. It's not physical evidence because we never been to the moon. We never been there to collect it, right? And
Right.
what we're saying is within the time of us knowing it and our current ability to do anything space wise or dealing with the moon, it's none that's active. But we know for sure that, like you said, and what to Aaron's point, that the moon has definitely been impacted. So even though the
let me
moon is
just say this: we
constantly-
can't actually say that there's no physical evidence because we actually have collected moon rock samples. So the moon rock samples themselves are evidence of volcanic activity. Our problem is we're not easily able to just get them and look at them.
How old are these moon rock samples that indicate volcanic activity?
I'm sorry, what'd you say?
Yeah, what's the age of the moon rock samples is what he's saying. What would the moon rocks that you're talking about, would they be younger than the 120-year time frame that we're being given for the activity? Is what we're asking.
Well, the moon rocks that they had picked up now, because some of y'all don't believe in the moon landing, but the moon rocks that they picked up, they claimed were between 1.9 billion and like 4.5 billion years old. Now, 4.5 billion is the accepted age of the Earth. 4.5 or 4.6 is about the accepted
Yeah,
age of the Sun.
so that's even further than what we're given. Chuck, you're saying billions of years. We said 120 million. So still, what we're saying is that even though you and everyone agrees, we all agree that the moon is constantly being bombarded with shit from space, be it motherfucking meteors, be it whatever, right? What we're saying is, and especially now, since we know we have the ability to clearly see and witness, right? If there would have been a volcanic activity, that there has been none since the, you know what I mean, since the ability to fucking explore the moon and see it and all these different things, so on and so forth. This is what we're saying.
Well,
So it's
but
nothing.
here's my question: how can you accept some of the evidence but not the rest?
What part of what are you saying? I'm confused.
Do you believe that we have moon rock samples here on Earth that are from the moon?
I believe it's possible to have moon rock samples because of parts of the moon breaking off possibly and being motherfucking coming down to the moon. I don't believe we collected none. No.
So that's part of, see, that's my problem, because if I want to point to the moon rock samples and I accept the fact that the multi-trillion-dollar government program went to the moon and brought moon samples back, but you don't believe in the moon samples, that's kind of an impasse.
Well, it's not an impasse. I'll give you credence. I'm either way it goes. I'm not refuting your information. I'm treating it as if you're correct and the moon shit happened. Be it fucking they picked it up, or be that it fucking drifted to the fucking, you know, made it through the atmosphere and it was collected on fucking the Earth's surface itself, right? What I'm saying is your information still coincides with what we're saying as to where it still has not happened and has not occurred since space observation has been possible, is what we're saying. You said 1 billion years, bro, and we're saying that the in fucking NASA or fucking what's name gives you the point of 120 million. So either way it goes, what we're saying, of in any recent times, bro, there has been no volcanic activity. That's all I'm saying.
Okay.
And just like my understanding for even here with volcanic activity, you have some volcanoes that go fucking dead after so long. So I mean that could be the case, especially we talking billions of years. So who knows? But yeah, and especially but either way. But appreciate you coming up, bro.
Okay. Oh, and by the way, I understand what you're trying to say about like no current moon activity, but one thing you got to remember is the reason why they have dark spots on the moon versus light spots is because they have a difference in basaltic rock versus granitic rock. Now, Earth, our continents are made of granitic rock because they're less dense, so they float above the basaltic rock. But on the moon, you don't have water. So because you don't have water, it's very easy for you to see that clear delineation, even if you're just looking at it through a telescope from here. So I would put that forward as proof that there's volcanic or has been volcanic activity on the moon. That's what I'm saying.
I'm not suggesting there hasn't. All I'm saying is there are newer craters than there is volcanic activity.
Yeah, that's all we're saying, bro. We're not refuting that. We're agreeing with that premise. What the premise you're not accepting is we're saying that there's clearly been craters created after the time frame that you're giving and that we're giving for the volcanic activity. Is always
No, absolutely. But all I'm saying is you have to remember there's a lot of things that happen, especially when something strikes at a high speed like that. There's a lot of heat. There's a lot of energy that is created. And because of that energy, we here on Earth, we don't even have enough science to study or observe long enough to be able to honestly say exactly what's happening on the moon. That's all I'm saying.
Yeah, I don't agree with that though. I
You don't agree with that?
No way. Because like I said, because we have telescopes and we have visual things to prove that or to take witness of it, be it satellites in space or be it telescopes from here.
A
So the
telescope doesn't tell you how much energy something hits the moon with.
Yeah, I'm not. It's not. Well, I'm not refuting the energy part, but but what you're saying would be the volcanic activity. So the molten rock that would come from that, you would definitely be able to tell if and when it was to happen. Don't you agree?
Well, okay, yeah, I could agree with that. Yeah.
Yeah, that's all I'm saying.
If it happened right now, because initially when I had come up, I was, that whole thing about the hard drives. No, as far the hard drives and the batteries, as these things exist, they are slowly losing mass. That's
the batteries again. I'm agreeing with you with the battery for sure. A battery is just degrades over time regardless. That's why there's until they make a renewable battery or battery that does not and it's impossible. Even rechargeable batteries do that, right? Just by nature, right? But the hard drive shit, yeah, I don't believe that because like especially in the quantum computing aspect of it, because like I say, if you're constantly adding data to something which is going to be energy, how is it therefore degrading, right? Truck, you got motherfucking hard drives that are older than me and you that still running to this day, bro.
Because what is etched on them is etched on them in a way that is recognized by whatever operating system you're using. It's like you're not taking, or I should say, you're not adding mass to the drive. You're just changing the surface of what is being read. So, because you got, and again, the hard drives all work a different way. Solid state drives don't work the same way hard drives do. Hard drives don't work the same way tape drives do. There's slight differences in how they store data.
We got you, but still, what Aaron's analogy of data being energy, and if you're constantly adding energy to something, at some point in time, like you said, that's going to become, especially, that's what I'm saying, because you're it's a transfer of the energy to, you see what I'm saying?
But keep in mind, when you add energy to something, you slowly wear it down.
No.
Yeah.
No.
Yeah.
No.
Name something that you add energy to that does not slowly wear down.
Wire.
Wire?
Yes.
Wire breaks down.
No, truck. No.
When you add electricity to copper wire, do parts of it not eventually start to melt? Do parts of it not like when you
No,
when you smell the burn?
No, Chuck, no. See, no. So now you're in my wheelhouse. So certain electrical anomalies that occur, if a short or something happened that's not a natural thing, yes, then that will cause the wire to be destroyed or degrade. Okay.
When you heat it up, right? When you heat it up, right?
Yeah, but no, this is naturally heated up. What I'm telling you, Chuck, is that the wire is graded for a certain thing. If you have let's say a surge of energy or something that's without the parameters, that's not the same as degradation. Wire don't just break down like that, bro.
Wire doesn't. So if that was the case, then we would never need to replace wire. The mere fact that the wire is there.
No, you're not listening, Truck. You're not listening, Truck. The wire either breaks down because of physical interference with the wire, meaning you break it or I break it, or the energy exceeds the fucking limitation of it. That's not just, it's constantly breaking down and degradation and so on and so forth. It's not like mechanics, Truck. If we're talking a machine and gears and stuff like that, yes, because of friction and different things and so on and so forth. Normal energy flow, that's again, Truck, we literally have it's power lines, Truck, that's never had to be replaced other than
Whoa, hold on. Fantastic. I'm gonna give you a new word you might not have heard before. Electromigration. Basically, when you run electric current through metal, it is slowly breaking down. I proved my point right there. Look up the word electromigration.
Okay. Okay.
So beside, and I'm not even talking about corrosion, and I'm not talking about mechanical fatigue, because that, like, if you're talking about a generator, that would be true because we're talking about friction. Electromigration alone, by the way, perfect example. The Navy thought that they were going to start building rail guns, right? The problem with rail guns is, even though they don't have powder and mechanical explosions, the problem is you still get the force of trying to force that sabot through that railgun. It creates 90-degree forces that push the rails apart. So my point is, everything is going to slowly break down, period. So it doesn't really matter if you even use that hard drive or not. The hard drive is slowly breaking down. Okay.
Electromagnetic.
You again, no. So hold on, because no, everything's not slowly breaking down. You it's literally elements that defy that, and it's clearly easily the fucking what's name. But so what are you saying in general, or are you just saying things that have energy going through them?
I believe I believe in the law of entropy that says all things are slowly breaking down and moving to a state of disorder. All things on an atomic and a subatomic level.
Yeah, disorder doesn't mean degradation, though. You're mixing words.
Right.
No, but the whole point of your order, you can't have order if the data was slowly breaking down, and we already account for that, and that's the reason why they have to use compression and algorithms, simply because if you leave data on anything, it will slowly break down. Doesn't matter if it's a DVD, a hard drive. I think we understand that by this point.
No. But are you saying the data or the medium itself?
Yeah.
Well, the data and the medium. I would argue the data
Chuck,
and the medium.
So Chuck, no, Chuck, no, because people I got fucking DVDs. This in a thing right now, Chuck.
And then they tell you that I have DVDs that the dye has fought. I swear to God, I got DVDs downstairs, and the dye in those DVDs has literally, you can see right through the DVD. Yeah, the dye's gone.
I got you, Chuck. Right, but that's you're conflicting what you're saying, right? So if you're saying in use, you have an argument, but even still, then that's not a all be all.
Watch this.
Go ahead. Yeah, go ahead, Aaron.
You ready? Can you state the second law of thermodynamics?
Yes.
Please do.
How do you want it?
The total entropy or disorder of an isolated system, right? That's the part you're missing. Isolated system. What you're talking about is degradation to systems that are not isolated. Yeah. They're integral and exposed to environmental things. What I would argue, is an isolated system.
I would argue that no system is isolated.
Well, then you're
No,
arguing that the
that's not true at all.
second law of thermodynamics doesn't exist.
Yeah. No.
No. I believe the law. I believe in the law itself. But what I'm saying is
The
that in
law
our case,
operates in the phenomenon of an isolated system. It's written in the law.
no, but I believe that in our case that it's not isolated the way, because we haven't created perfect isolated systems. That's what I'm saying.
No, exactly. Yeah, but that doesn't mean that what I'm postulating is true if according to the second law of thermodynamics. Can you read the screen?
Wait.
Make it bigger.
It's a little.
Make it bigger. Pause. Aaron, make it.
Okay. So it says solid state drives technically get heavier when full. Yeah, that's a solid state drive. A hard drive and a solid state drive. See, the difference is a solid state drive is non-volatile. They have to use electricity in it in order to keep the thing running.
Hold up. Sure. So stay right there though. But he still supported his point, and he proved it as to where the data creates mass. Is what we're saying.
No. But see, here's the problem. As I stated before, not all drives are the same. Hard drives don't work the same way. Non-volatile memory doesn't work the same.
But again, truck, we're not refuting that, truck. What we're saying is to the point of the drive that we're speaking to, which would be a fucking quantum computer, which is going to be more like a solid state drive, a highly functioning solid state drive is what we're saying. So it's accurate to the point of what we was talking to, truck.
Well, okay, no. Well, if you believe that, because first of all, quantum computers have not been
you right here.
Hold on, quantum computers are still theoretical. They haven't fully been completed. There's not a single quantum computer on the market that you can buy.
Well, not you can't buy one, but it's definitely one that's already in production right now.
Do me a favor, name it because I haven't seen any.
Oh, just truck. When the fuck did you see your first iPhone, truck?
iPhone is not a quantum computer.
The point is, motherfucker, it was there way before you ever had it in your hand.
You believe that SSD drives are going to be what the quantum computers use, but there's always a possibility that they come up with a different drive.
That's not what I'm saying. I am saying it's going to be something similar to, or the concept is going to be the basis of it, and then it's going to be, of course, far more complex. But it's the same fucking principle is what we saying, truck. At the end of the day, okay, you're wrong, motherfucker. Like,
no, I don't think I am.
You are. You're reading it right here.
No, because I said specifically, all drives don't work the same way. These are not. Okay. These are non-volatile.
Okay, but to your understanding of what a quantum computer is a quantum computer very, very similar to, or if not fucking identical to, a motherfucking solid state drive?
They don't have any working models of quantum computers right now. A lot of those are scams.
Truck, man. You have a good night, truck. I'm not doing this with you, nigga. Jesus Christ, bro. My bad, Aaron. My bad,
no
man.
Problem.
You got a little bit of hair growing back, Aaron. That kind of helped you a little bit, bro. I see a little hair growing at the top, man. That's truck, though, man. Shout out to truck, bro.
Hey, listen, man. I would be a scientist if I didn't welcome pushback. You know what I mean? Like, theory has to be challenged. You know what I mean? So.
At the end, because at the end of the day, like I said, you showed the evidence to support your hypothesis. In theory, it's on and so forth, or actually the law that already exists, and that serves the purpose. So yeah, everything worked out, man. Yeah, that's what I'm talking about, man. It works. It works.
Even said you got to use electricity in a solid state drive to impart data on the side, right? And what did I say? Electricity is the energy that gets converted into mass.
Exactly. What were you saying? That's like, bro. You like, hey. I'm not. I can't talk shit about that motherfucking quantum computer, but that electricity shit. Nah. Hey, I know that.
Exactly.
But, so that's what I was saying, Aaron. So then too, when you talk about volatility, you talk about energy, right? We know the quantum computer is going to be processing, like you said, enough data that would be the equivalent of a fucking atomic bomb, bro. So this is constant firing, constant. So like you said, yeah, that would be theoretically that would be very, very dangerous if you're on the planet.
A lot of energy, a lot of mass, however you want to look at it. Information, mass, and energy are all interchangeable.
Yes.
Especially if they say a black hole is so massive that it won't let anything escape, not even energy. And what happens in a black hole, energy information seems to disappear. It seems to be destroyed. Information, energy, and math are all interchangeable.
Indeed. But hey, man, I appreciate you for pulling it up on me, man. I apologize for that quick blood pressure rush, brother. Yeah, but that's truck, man.
All good, man.
That's truck, man. Appreciate you, Eric, for pulling up, bro.
Yes, sir, man.
For sure. Hey, people. Another Tinfoil Tuesdays down. If and when you have a good idea or whatever, you have some understanding, please don't let the government know, because they'll kill your ass. Straight like that. Okay. Hold up, Truck, you still here? Truck, what you want to fucking talk shit before you leave, bro? Truck. He ain't know you here. He ain't even leave. Either way. Hey, greatly appreciate y'all pull up on me, man. I think if Tommy's live, he got a spot. I'm gonna be over there. So pull up on and I think Melanin. If she's live, let me see. Melanin don't got her damn what's name on, man. I gotta tell Melanin to turn on her I gotta tell her to turn on her what's the name thing, so I can send people over there to her when she get done. Give me a second. What y'all think about the thumbnail, bro? Killing his thumbnail shit. All right, killing his thumbnail shit. I do need another damn what's the name though, bro, because they be having too many fucking restrictions, bro. Too many restrictions. Yeah, that shit. She not on the thing, but I'm pretty sure she on the other thing. But whatever, fuck it. Well, anyway, man. Hey, Mr. Fantastic 824 on all social media platforms, man. Make sure y'all like, comment, share, subscribe, and hype the video. That's that on that one. We'll catch you on the next one. Holla, we out.